do that to sync the camera and audio, what the clap was for, so. At any rate, everybody can make the turbine training. This is supposedly will address, questions people have had ever since machine personnel taken over turbine operation. This has been a long time coming. We know people have been operating just kind of by the seat of the pants. And we have with us today Curtis Jones from Dress Around Corporation. Now, Curtis is not what you call a professional trainer. This guy is hands-on. He knows, he's capable of training, but he actually gets out there in the field and works on these things. He knows that we're talking about from an operations standpoint, what you guys need to know. He's going to take you through some of the basics of the turbine operation. He's going to give you some cause and effect, why things happen, why you want to operate within certain ranges or whatever. And you're going to have every opportunity in the world to get your questions answered from Curtis. We're going to go and have lunch about 11:30. Then we're going to go over to the mill and actually go out on these turbines to where if you have specific questions that you want to point to a valve or something like that, you can ask Curtis and he can help you out with. So, Curtis, appreciate you being here.
Thank you. Thank you. Kevin said, I'm a project manager for Dress Around Field Services. I coordinate the crews and provide technical support for my crews and to help make the jobs skip along a little easier. So, I guess our main objective for today is going to be to cover startup procedures, the loading of the machines, and the shutting down of the machines. You see it so many times that it just takes away from the life of a machine the way it's operating. You know, you just can't go there. So many people think you just go open the valve and light it off. It's not an electric motor, and there are a lot of repercussions from improper startup and shut down. So, like I say, if you have any questions throughout this, just let me know. We'll stop and answer them, and we'll carry on. Here we have a little, just kind of a brief course objectives. Listen to recommended pre-checks and precautions associated with starting the steam turbine. We're going to describe the major steps in starting the steam turbine, identify limitations, explain the necessary steps for properly shutting down the machine. But shutting it down is just as important as starting it up. Because you go start it next time, it's not been shut down right, you're going to have problems with bows in the shafts. You're going to see vibration in the beginning. If you shut it down too quick, a lot of times there's a rotor, which I don't know if y'all are familiar with the rotor, that's the rotating assembly inside. If you shut it down too quick, there's still a lot of heat in the machine. It takes a bow. And sometimes it takes longer once you're bringing the machine up to roll that bow out of it, because you got to get the heat back in it. So it's just as important shutting them down as it is starting them up. This is a training course we have for Dress Around some of our mechanics when they're coming in. So this covers 6 different lessons: preparation, startup, warming up, the gland seal system. You have overspeed testing, and operation loading, unloading, unloading and stopping. Excuse me. Hard to read that, right in blue, but anyway. Turbines they're made to run. They're not made to sit on hot standby. See, a lot of people try to keep machines, like people order pump turbines, keep one on hot standby. Well, they're made to run. You let them sit, they just cook themselves. Because if you're heating them with back pressure steam, the seals are designed to seal at operating conditions, not at back pressure steam. The temperatures are not high enough for the thermal growth to really come in and affect and accomplish the right clearance in the seals. So they're set up to run. Machine's a lot better running than it is that. And you see problems, start seeing problems in the seal areas, fitting in the shaft, and then when you do start it up, you have lots of trouble. You need to pretty sure that we've gotten up-to-date manuals for the two machines we had, the one TS4 and the 703, the vacuum pump turbine. I'm pretty sure Ricky's got updated manuals. It's something we can all look through, and it gives you a brief overview of to the startup procedures and what to be, keep your eyes open for. So, they'll help as well. When you get ready, when we prepare for startup, there's a lot of things you can walk around and look and check. I'm sure y'all all try to do that. You need to check and make sure your oil's on. You know how many times I run into a situation, man, they go start a valve, open the inlet valve and roll it off, and this oil pumps ain't running. They'll bypass the interlock or something, have problems with the interlock and light it off, and it don't take long. So you can check your casing drains, your down leg drains on your steam lines. They need to be open and they need to be drained. Because you start a machine and it's at a temperature and it gets a shot of water through there, it really wreaks havoc on the shaft. You got a machine there, rotor's 500 degrees and it gets a shot of water, it's tough on it. You can look, once you got all systems up and running, walk around, look at your oil seals, make sure you're not seeing any leaks around the bearing housings, make sure you have proper flow through your drains. So, it's a lot of little things you can do. Everybody needs to get in a little routine of things to check and things to look at. As I was saying before, that's another situation where people try to get in a hurry, start the machine, and in the long run, it costs them time. If you take the time to open your casing drains, open all your casing drains, open your drain lines on your exhaust line and your inlet line, and blow. Just let them go till you don't see any moisture. A lot of times that's hard to do with the way people's systems are set up. But you need to get as much water out of it as you can. Because if you start it with water in it, you're going to see it in the seals, it's going to wear on the seals, it's going to wear on the shaft. You'll start seeing a lot on the tail end of the machine, the latter stages of the machine. You'll see wearing and washing on the blades, the shroud rings, and then it's tough on it.
You supposed to open them drains on a hot shutdown.
Mm-hmm. Need to open them drains before you.
On a hot shutdown.
Yeah. You need to open them up and let them go. Most of the time when I start a turbine and run it till it's fully loaded.
Even when the 435 is open,
Mm-hmm.
you can open the drain.
Yeah. Most of the time I start a turbine and run it until it's loaded, till you've got a load on that machine with the drains open. Now people don't like to do that, but it's so loud. You have steam blowing everywhere. But you're not getting full flow through that machine until you're loaded up and you got all the horsepower out of it you can get. And that's when you pick up steam, excess water in the lines, and here it comes. You'll see the machine, when you're monitoring vibration, you can tell exactly when a shot of water comes through there. No matter if it's a thimble full or a bucket full. That old machine will shake and shimmer, and that's when you start seeing it'll start jumping in the bearings. You'll see unusual wear patterns. A lot of times you'll see spots in the upper half of the bearing where the rotor will jump. And it's just, and as you're coming down, if you go ahead and open them drains up, it'll let some of that water go ahead and come on down and get out of the machine. So when you get ready to start up, you don't have it right there staring you in the face as much. I've seen that happen. I've seen so many rotors killed with water. I mean, it's just amazing that people just, they go start a machine up and they're opening lines and you got a machine up and running, there's water shooting out of both ends of it. And that's, you'll get through it, machine will come up and run, but then it'll just kill the life of the machine. It'll really tear the blades up. So,
We had a shut the turbine down this week,
Uh-huh.
and it was a hot shutdown.
Uh,
We shut the throttle valve, but we didn't drain no, bleed nothing off. It just, that's all we done.
Yeah, just quick.
That's all we know to do.
Yeah. You shut that, when you go ahead and shut, when that throttle valve shuts, you go there and crack them drains up. Just let them go. You got above seat and below seat drain in the valve. If you go ahead and open that above seat, it'll help take that moisture right on out as it's cooling down and get the water out of it.
There's no time limit on a hot shutdown. You can stay down long as you want on a hot shutdown.
But just leave the drains open the whole
Just
time.
leave them open. I would. It just helps it keep circulating coming on through, you know, instead of stonewalling and building a whole wall of water there. Then you got less time when you get ready to start up, you have less water in the system, you know. See, all those drain lines are normally left open. It is good practice to verify their open position. The inlet and exhaust piping as well as the gland seal system should be blown down with hot pressurized steam. This will remove any water that might have accumulated piping as well as preheat the piping. And again, there we're stressing the importance of getting the water out of them, because they're not compressors, they're not pumps, you know. It's I was just telling Kevin, I got a guy that's I got a job going right now at a machine that's it's really bad, really bad shape. I mean, it's but due to water, due to just going there and starting it up and letting it go, and you know, they're looking at reblades. You know, that water is like BBs when it comes to there hitting those blades. And it's just, when it gets in, it just knocks holes in. It'll look like somebody shot it with a birdshot. And before you know it, you got holes in the blades, and then you got it's a costly repair when you get a reblading one. So, and you can hardly see that. Can y'all see that all right? It's kind of hard to see. That's just a little review questions of that little first little segment we had there. I couldn't hardly see that neither when I printed it out. It was about 2 in the morning in my office. So, first step in operating a steam turbine is start the auxiliary system associated, review the plant's operating instructions for the turbine, align the inlet and exhaust pipe. Which one of them would y'all say is the answer to that is to review the plant's operating instructions for the turbine. Get everybody up to speed. Everybody looking at, get on the same page. You need to have a plan no matter, you know, anything you do. That's a big thing with Dress Rand is we all stop and have plans for every job we do, every task on that job. We have little gang box meetings and we set up, everybody knows what everybody's doing, so nothing gets overlooked. And it,
Curtis, I think that's a big reason you're here, is because I don't think anybody's doing anything the same way, because they don't have the knowledge, they don't have the information they've been needing.
right.
And so hopefully we'll come away from this at the end of the week, and everybody will be on the same page as far as the ideas of how we deal with turbine operation.
Good. That's what we're gonna try to put into place. It really seems to help with our guys. It's cut down on a lot of warranty issues we've had. A lot of, you know, we're at, it's helping our safety. We're at 6 million man hours without a lost time. So, and we run 400 mechanics a week in the field worldwide. So, it's really helped us to establish these procedures and kind of keep everybody up to speed, you know. It's not probably this type of work is not the best working environment, and so you have to take those precautions. And it's so loud, you know, when you're starting a machine up, it's hard to communicate within the people, you know. If you know in your head what's going on, you can see the guy over here and see what he's doing, you know what he's doing, see what's been done. Another little question here. Prior to starting a turbine, a visual inspection of the machine would show which of the following problems: high vibration levels, an excessive steam leak, insufficient steam supply, improperly designed components within the turbine. Which Which one of them would you guys say? So maybe excessive steam leaks, you see it in the seals, you see it around the shaft, and, you really can't, you wouldn't be able to tell vibration until you got up to speed or coming up. Insufficient steam supply, you wouldn't see that, be able to see that unless you were loading the machine and, you were seeing a fall off in your horsepower. Proper design components, that's more of a manufacturer's type situation. So the right answer to that is excessive steam leaks. Can y'all hear me all right? Why is it important to open all drain lines prior to starting the turbine? To allow the flow of steam through the turbine, to remove any water from the turbine and associated steam line, to prevent overpressuring the turbine case, to allow operators to see when steam is flowing through the turbine. I'm assuming to remove any water from the turbine. That's, we talked about that. I can't hound on that enough. You know, I was the supervisor for one of our repair centers in Baton Rouge for 6 years. And so, I can't tell you how many jobs around our shop due to water. Just rotors tore all to pieces. You know, it's you try so many times to explain that, and a lot of times production won't allow you to, or they don't want to allow you, because they want to get it up and running, you know.
Curtis, before we start the next section, we take a short break here. Yeah, coffee's ready.
Okay.
And, what you talked about the water, that's the thing I keep hearing over and over from crew, is the condensate in the oil system and the turbine.
Mm-hmm.
So, coffee's ready, take a short break.
Right outside this door. Yeah.
We're gonna go over here and eat 11:30, and then we gotta come back over here and go.
And it'll hit.
How much be over?
I'm not going crazy, I just have to send you out a little video by doing that every time.
We got scheduled.
Well, I am going crazy, but that's part of it. All right.
We can get done before 8:30.
Curtis, you give me a sec, please.
I'll have a casual conversation on that here.
Do y'all have any questions so far for that? I can touch base on that I haven't.
Yeah, when you shut that thing down for an outage, like an all-day thing, cold shut down, you're supposed to leave that oil system running an hour and a half before you shut it down.
You need to leave the oil system running until you get the temperature out of the oil. Because if you shut it down, it's not gonna pull the heat away from your bearings. Those bearings are Babbitt line. You start seeing the lamination in Babbitt somewhere in the 225, 230 range. So all it does is, if you don't keep circulating oil until your oil temperature gets down, you know, and get the heat out of the bearings, you're gonna see problems. It'll start delaminating the Babbitt. It's not about 50 thousandths thick on those bearings, and it's bonded to a stainless steel backing, and it'll start popping off. You'll see chips of it coming off. So you need to leave that oil on until you start seeing the heat come on out of it, get on down, you know. Most times at 100 degrees, something like that, you can start shutting down somewhere in there. But if you can leave it running, if you're not gonna do anything to the oil system, it doesn't hurt, just keep it running. Just keep it running.
It won't hurt nothing, leave it out.
No, just leave it running. There's no need to even shut it down.
Well, I've heard 2 or 3 times this oil system we got is like obsolete.
Which machine is that on? 20.
This
If-
Bowser.
Yeah, that's an old system, GE system. I first got started in this right out of high school, and I worked with GE Traveling Maintenance, and that was one of that's a hair puller there. It's not really efficient, you know. There's a lot of, it's just like everything else, you know, you can buy a TV today, and then tomorrow it's obsolete, and it's got antiquated parts on it. So, there are some things you can do to upgrade systems, and we have a process innovation group they're applied technology that comes in, they survey your your flows and your conditions and upgrade the system and helps you maintain. And there's a lot of things you can do to an oil system as far as your turbine, operating your turbine, that'll improve even the old system, you know, the way you, again, we're right back to the startup. If you don't get that machine dried out and you get through a lot of vibration in the beginning, there goes your total overhaul. Because when it's vibrating, you have elaborate seals on the multi-stage machines, you have carbon seals on the single-stage machine. It goes vibrating. You're running 12 to 16,000 clearance in the seals. It's vibrating. That shaft's just jumping all around and it beats your clearance right out. You're right back where you started. So basically, you know, you've thrown a $100,000 overhaul right out the window. And because I don't know how many times if y'all ever seen, y'all seen the turbines opened up.
Oh, yeah.
And when you open them up, every time you'll see seals where they've rubbed and touched off. 98% of the time it's touched off on the initial starter. Because once it's up and laid out, it's not gonna touch. It's right where it's gonna run. And when you start them up and they're vibrating and they go through criticals, and that's another thing we'll touch on, and you're going through a critical speed, you need it going through it. So many times you see an operator, he get up there and start going through a critical and they go to shake it, they want to run dive underneath the handrail. You need to go through it, because that shaft's just flopping over itself in there. And it's just taking out all your clearance and all your efficiency. And once those seals are like, you start blowing steam down the shaft. And then like on the 19th machine, that bearing housing is so big up front, with that steam blowing out on it, it makes a rainforest. Basically what they do, when they pull that top thrust housing off, you'll see rust spots up under there. That's where condensate just build up under there and it drips off in the oil system. Then you see it in the reservoir down there. You all start looking like milk. There's another question. What would be the normal run temperature on the oil system? Well, it varies. We like most of the time the oil temperature in the 140 to 160. Well, good, because we got an engineer who just come over there and started making us run to 120 degrees. That's too cold. He said that is manufacturer spec on the oil, and then he goes in behind us and then still running back down to 120 degrees. 120 degrees, you really don't get the flow. We got white oil. That's right, you don't get enough heat in it to get it to flow right. You start seeing just different repercussions of that. If you get it too much colder than that, you're gonna start seeing oil whips in your bearings. They're pressure down bearings in most of them, and what it do is just start whipping in there, and it doesn't give an even film because the bearings have little dams in them that hold the oil. And at 120 degrees, you're getting down there pretty cool, you know. Right, that was the thing, we go down there and we just hold back, we got our pipe, because it always is iron and oil. And it was in the old steam plant when they showed us, it's 140, 160 degrees, keep it in there, keep the water flash out of oil. There's no, manufacturer spec on oil, 120 degrees. But it's not the operation spec on the manufacturer. You know, there's just, the manufacturer of oil has a different spec for his oil, but we apply it and implement it in our operating conditions of our machine. This is the temperatures we need to operate in your machine, you know, in the machine. So you need to turn it back up to 150, 160 and break the knob off there. Yeah, I did that yesterday. Okay. I didn't break the knob off, but I thought I put a chain around it. Yeah, just break the knob off. That'd be the end of the day. So, there are many support systems on the steam turbine. These support systems need the operation prior to starting the turbine. You check your oil level in your reservoir. You know, if you got your oil system been down, everything's empty. When you go start up, if you're at minimum level on startup, and it goes filling all that pipe and all them bearing houses, you're gonna be down there pretty close to where you don't need to be. You check your mains, you shut down on your main, your auxiliaries, you start up your pressure switches and make sure everything's operating.
You need to start that oil system at a certain time before you start up, or does it matter?
You need to start the oil system.
If it's been down all day, if it's been down all day.
You need to start it first. Go ahead and get it
Like an hour or
circulated.
two before you start up, or does it matter?
Well, you need to start it, go ahead and start your oil system and open your exhaust line, start getting some heat in the machine, bringing your oil temperatures up. You got to heat that oil up before you can go. You know, I do a lot of work in the power generating, in the substations and the cogen plants, and they're in a hurry to get those machines back. And I've seen them try to start so many times at low, cold oil pressure, and you get a 500 megawatt machine, which is a big machine, doing an oil whip, it'll shake the whole house. So you need to start the oil system up as soon as you can. Even if you don't have steam induced into the turbine, it'll start heating it up, circulating. It'll start warming that oil up. And that's you can't start up too early. You know, once after overhaul stuff, make sure all your instrumentation's in, everything's ready to go. That's the first thing I do, go ahead and start the oil up. Let it go ahead and start circulating. We can check for oil leaks. Yeah, that's a good time to walk around and check for oil leaks. And that's something you need to do the whole time prior to starting, checking oil leaks. Because when the oil's cold, it don't leak as bad as it does when it's hot, because the viscosity gets higher. You know, when it starts warming up, it'll start creeping, and you know that's when you'll have a leak, when the oil starts getting warm. But you can't start it up none too early.
Basically what you're saying, if you leave the oil running even on the shutdown,
Yeah.
just leave it running unless you're gonna change oil, change filters or so forth.
If you're not gonna do anything to the oil system, let it go.
Let it go.
Let it go. It's not gonna hurt a thing. Because it's a whole lot different than, you know, like a land seal system or steam lines. You're not gonna put enough heat because you're gonna be cooling down if you're doing anything, because you run through the cooler, so you're not implementing any more heat into the machine. So if I'm not gonna do anything to the lube oil system, just no need to shut it down. I'm getting ready to get talking, didn't have nothing else up there. Bear with my fingers, a little crooked and broken anytime you call me hand in a little piece of paper. And again, we were talking about once you start that system up, look at those targets. Make sure. I just went through not too long ago with an operator that saved a failure by just so happening looking at that. We had touched base with him. I'd gone in and just talked to him a little bit, and he saved the turbine because of that. He didn't have sufficient oil flow coming out the thrust end bearing housing through the bullseye, and he just happened to see it at 3 in the morning. I'd have never caught it. You know, we start up some machines, it's like repetition for me, you know, and I don't know how he caught it, but he did. And we went in, and the oil supply line, a shim had gone over the top of the oil supply to the thrust bearing. And he saved the machine, he did good, so that's a pretty easy thing to look at, and a lot of sight glasses you can't hardly see through. And that's something that needs to be addressed on down days when you have time or outages. You know, a $100 sight glass is a lot cheaper than a $100,000 rebuild. And I can't iterate the fact, you know, a lot of these machines, they don't have the new technology on them as far as monitoring devices. And it's just as simple as a thermometer, being able to read it, or a sight glass. You know, if you can't see through them or you can't read it, you just will take that out and throw it in the trash. And that's the only warning systems you have on a machine with no instrumentation. So
They want to replace half of them anyway. On the line shaft, everyone is four gauges broke.
yeah.
And then on the vacuum turbine, center and base on 19, there's two. And they say broke all the time.
So people get up there and get to work on something, and they sit down on them, step on them, and they turn them with the faces straight up.
Yep.
So then there you go, everything drips down on them, and then you go over trying to wipe them. Time to get it wiped off and cleaned, you look, it ain't working nowhere. This is a little verify that oil temperature to the bearing is correct temperature. Proper oil temperature varies from turbine to turbine. However, steam turbine manufacturers generally require oil temperature at least 9. Now and I can tell you, and I'm gonna tell you, like all y'all know, there's so many, our engineering group at our factories that build them day in and day out, don't see a machine run. And there's so many times that, I've had our own engineering group tell me by design it can't do that. Well, I'm telling you it does. And then when they made up these oil temperature charts, they're low on the bottom side, just like you were saying. You know, machine runs better, it's smoother, if the oil is in the 140 to 160 range. Here they're showing down about where you were speaking about. The 90's a little cold, so on the initial startup, but you can refer to your manual and it'll give you some idea. But I'm just here to tell you, I start up a bunch of these things every year, and you stay in the 140 to 160 range, you're good right there. A little bit contradicting to that piece of I probably throw that in the trash.
Put that aside there.
Yeah, we'll cull that one. Is the machine a back pressure or exhaust pressure machine? Use the exhaust steam line to preheat the turbine internal components. That's very important on two accounts. If you open the exhaust, you know how many times I've seen people blow turbine cases up. They'll go to warm up with the inlet line, which is 600 or something, and the exhaust line closed. It just overpressures the case. So you go ahead and open your drains on the block valve on the exhaust line and let it blow down, and then go ahead and open it up and get some steam going in it. So do this either opening the exhaust bypass valve you've installed. A lot of people have little bypass lines coming above the block valve, coming back in around the valve that they can open up and get some steam through, so you're not having to wrestle with the big valve just to heat the machine up. I don't know, I can't remember that your machines are equipped with that. They're like a little 1-inch line that just comes out around. It has a valve in it where you can open and bypass your main exhaust line valve. A lot of it, they call them startup valves, preheat
We got
valves.
it, yeah, we got one on.
Let's see when you get over this afternoon.
Yeah, we can look at that.
This point has got there.
So it's just giving you some idea on warming up. Like I say, get the heat everything up with exhaust steam. Start getting some heat into it, start getting the rotor growing. Because the rotor don't only grow in diameter, it grows in length. And the turbine is set up, the case is set up to grow. That's why we have wobble feet on the thrust end. This time they grow back towards the thrust end. That's why the wobble foot is there, to let it flex. And they're set up for the rotor to grow one way and the turbine to grow the other. So it pretty much stays, as far as the actual location, within itself. Starting and warm up. Reset all shutdowns and make sure that the trip valve is in the latch position. It's good practice to manually trip the trip valve and make sure it's fully closed. Once verified, place the trip valve back in the latch position. That is your length between a running turbine and a basket full of small parts. If that don't work, it ain't good. And I just walked off a job about 2 weeks ago on a man that wouldn't go into his trip valve. And I tried to explain to him, that don't work, we're in trouble. And he opened his with a pipe wrench. And that's a very, you need to check the trip mechanism. I can't, you can check that by putting it in the latch position, killing the oil pump. And it trips, and you'll hear it slam shut. It can't reiterate fast enough how important that is. That's something that needs to be looked at on a regular basis.
This is just like a emergency shutdown.
That shuts the steam flow. I mean, when it trips, it shuts the steam line. It closes everything off right then. And on a machine that's not loaded, when you don't have a lot of load on it, I can run a single stage turbine like a vacuum pump turbine on a 1-inch airline. I can run it double speed. So it don't take a lot to run a machine. And when you're uncoupled to verify trip speed, you don't have a load on it. If that don't work, that seat, if it don't slam all the way shut, all you had to have was like a 1/4 inch off of the seat, and that machine will go right on. So, that's very important. There's a lot of small parts in those machines, in those valves, that have to work. And they will operate under such harsh conditions, that's something that needs to be inspected and taken care of on a regular basis. You know, all your pins and bushings need to be greased, you need to check the spring in it, because a lot of times the valve runs, say it stays running for a year. It's compressed, it loses its free length, therefore it loses its tension to shut the valve. So that's something you need to look at on a regular basis. And I think that's what we did on the last time, on 19, we went through and operated the valve and greased everything and make sure everything was ready to go. With that, I like for that thing to be able to work when I'm starting up. Y'all probably tell I ain't built for speed, I don't like running, so. If the machine is an exhaust pressure machine and the turbine case was preheated using a bypass valve and the exhaust line, make sure the main exhaust line isolation valve is fully open. If this isolation valve is not open fully, the operator runs the risk of overpressuring the turbine case once the unit is started. And I can tell you right now, you can flow more steam in a machine with that 600-pound line than you can exhaust on that 1-inch, 90-pound Sentinel. So, and that's, I've seen that before, and that's not I saw a customer swell up a little turbine like a pumpkin. It's one of the cases it does. Has the back pressure steam turbine case preheated? By using exhaust steam to preheat the case, by cracking open the inlet line, by opening the turbine case drain valve, or by convection from the surrounding steam lines. Gonna be by using the exhaust steam to preheat the case. So, there again, that's pretty important. That's why I go back to get the water out of it before you can crack it open. A lot of times the exhaust lines, they're cold and they'll have a 12-foot down leg coming down from a 90, and that whole thing will be full. Somebody thinks they go there and kick the valve open and it drains in 5 minutes. That's not the case. You can take your leather glove and go over there and wave in front of it. That glove comes out sopping wet. You know, you might not see the water because you got steam going everywhere. Your glasses fogged up. You're fumbling around there trying to keep them getting burnt. If you'll go there and wave your glove in front of it, it'll come up, it'll have water all over it. You just keep watching it until it starts going away. Before you ever crack your big valve, just start putting some steam in there on the exhaust line. The gland condensing system primary function off. To remove steam from the turbine and prevent air leakage, remove air from the turbine and prevent water from blowing into the atmosphere, remove air from the turbine and prevent steam from blowing into the atmosphere, remove steam from the turbine and allow air leakage into the turbine. I think that was part they pulled out, that's the quiz in there. But the answer to that is remove air from the turbine to prevent steam from blowing into the atmosphere. So those machines are set up with gland seal condensers that'll pull a vacuum and pull off your packing glands. And you can, as you're starting up, you'll see your leakage down your steam, down your shaft. You can start opening that up and it'll pull it right on. A lot of people have injectors, and I think you got injectors on 19 that you can, that basically they just run wide open and pull off there. It's not a vacuum kind of, you don't have a auger on it that you can monitor vacuum. The exhaust line isolation valve was not fully open, what could happen to the turbine? It would allow the flow of steam through the turbine. The exhaust case could be overpressured during operation. nothing, the turbine will operate fine. The operators could not see when steam is flowing through the turbine. I think we all know what that is. The case could be overpressure. And, that's, we don't wanna go there. The next phase for starting a steam turbine consists of warming up this turbine and bringing the machine up to rated speed. During this phase, the turbine is heating up and expanding, as well as increasing its speed. Depending on the style of governor or trip valve used, the procedure required for starting could be pressing the run button on the governor or manually opening the valves that can control the flow of steam into the turbine. And that's, startup is, that's just part of, you know, when you start it minimum, what you can control the machine at. I know a lot of them, you know, they won't say 500 like that illustration shows, but you can't control them on the bottom end like that at 500. Most times it's in the 700-800 RPM range, and they're hard to control when they're at low RPMs like that. You know, you have a erratic steam flow, you're not getting enough flow through the machine to really control it. It'll hunt. Just get it at a stable, low RPM, and let it sit there and run. And that's putting your inlet steam temperature in, your pressure, and it's getting the rotor the final thermal growth it needs for the seals to operate properly. So, just run it right there, and just let it stay there, and let it lay out and stabilize, and let it run. Go get you a coat and come back. Just let it go. You can't run too long at low RPMs like that. It'll really, if anything, it'll help you, because it'll help take the bow out of the shaft that it might have taken while it's down. It gets all the heat into it, it gets everything rolling good. You know, on bigger machines, I've rolled 24 hours like that. Just let them, you know, that's a big 500, 600, 700 megawatt machine, but still, it's a pretty important process. I know in 19, I think most time they were starting up within 15 or 20 minutes after starting up, after putting heat in it, after it was rolling, they were starting to increase speeds. Most time when that machine is a long machine. It's got a spindly rotor and small bearing drum is what I'm referring to. So you need to roll it 45 minutes, an hour like that, and get it to lay out and get it where it needs to be when you go. I say, if y'all have any questions, just stop me anytime. Starting limitations would be due to one or more of the following conditions: case of rotor differential expansion, distortion, and internal misalignment, coupling misalignment, vibration, and thermal stress. The above conditions may be produced by excessive rates of temperature change, and one of these may be a limitation, although others may contribute to varying degrees. These are all related to temperature, which may be the result of load or steam supply. The casing and differential pressure, that's what I'm saying. When you open your steam line and you start getting inlet steam pressure and temperatures in there, you need to let the temperature of the rotor and your inlet temperatures kind of, you know, become closer before you start up. Therefore, you get all your thermal growth and your seals work properly. You know, when we set up seals, whether it be carbon rings or labyrinth seals, the design clearance is set by, or is determined by the amount of thermal growth in a shaft, thermal growth of a machine. And if you're running below that, your seals aren't going to work properly. So, on the distortion and internal misalignment, that's referring to the diaphragms. You know, we put when you overhaul a machine, you pull all the diaphragms, all the internals out, and you get ready to go back. You put the diaphragms in, you put a mandrel, alignment mandrel in the bearings, and you align everything inside so it's true, straight and true, and you have it sitting low enough that it compensates where you, at operating speed, your rotor, theoretically speaking, it's supposed to be right in the middle of your shaft. We'll try to get it close as we can. Sometimes it'll pick up a rub on the way down, on the way up, and you'll hear it. Most time it'll rub out, and you'll just let it lay there and the rotor will start straightening out too as well, so. Government misalignment, you know, we talked about that earlier. That's something that, I don't, do y'all have, laser alignments? Yeah, that's something that's, gets overlooked so many times, you know, you treat the symptom but don't cure the real chronic problem, you know? Government alignment is very crucial, especially in a small machine, you know, a small single stage machine, because the rotor's so light. If you have any type of coupling misalignment, you're gonna see bad wear patterns in the bearings. It's gonna run offside, you know, it's not gonna lay in the bottom of the bearings, it's gonna run sideways, it's gonna run up, whatever. You know, a misalignment affects a small machine, not one that does a big machine. Vibration, we don't really have do you have means of monitoring vibrations?
I have a crew that does that, goes around and monitors those.
But as far as being able to monitor it on a day-to-day, 24-hour-a-day basis,
Usually the vibration is when somebody suspects there's a problem. They do, don't do routine kind of route, but on the other hand, if there's a demand for a certain area they're concerned about, they'll monitor it more when it's asked for.
that's right. But on 19, that spare rotor we had rebuilt when we took out last spring, I think it was, we set that machine up, we went ahead and put pro bearings on that machine. And Anthony was talking about setting up a vibration system where we can monitor vibration.
Andy Blackwell, he's on one to run at 120 degrees. Let me talk to him.
Before starting a steam turbine, the operator should understand the various speed relationships encountered during startup. The chart below lists these speeds, and they will be discussed as you progress through the course. It is important that operators understand their responsibilities when they accelerate the steam turbine from 0 to normal operating speed. So, this is like I was saying before, when you come up to idle speed, you need to let it sit there and run until everything gets, until you feel comfortable and you've got enough temperature into it. And that's pretty much something you learn through starting it up several times. You know when that machine is warm, you know when it's ready to go. Like on the vacuum pump turbine, most of the time on that little single stage, and you got some over in the powerhouse too, the 703s and the 505s, and you can most of the time 20 to 30 minutes run them at idle speed, and then go ahead and take them on up. Like the one on 19, the line shaft, you need to run it a little bit longer. It's a longer machine, longer rotor. They have small journals. You know, you're looking at a rotor, 1,100-pound rotor, it's got 2-inch bearing journals on the thrust end. So you need to get it up and get it warm before you start increasing speed. Most of the time I take it from idle speed up to, say if idle speed is 700 or 800 RPMs, I take it up to 1,200. And I let it lay down right there and smooth out and get up, you know, you get more steam flow through it, just let it lay down. Let it lay there for 15, 20 minutes. And you can take it up in 1,000 RPM increments. But whatever you do as you're taking it up, don't get caught in critical speed. And I don't know if y'all are familiar with what happens during the critical speed, but all the shafts run with bows in them. Just the laws of gravity, it's gonna have a bow in it. And what happens at a critical speed, that rotor is running with a bow in it. And at critical speed, that bow starts going over top of itself. It'll start tumbling like an orbital effect. And that's when you go to wiping out seals. So when you need to stop right below a critical speed or above it. Don't get hung up in the middle. A lot of times I say people try to stop it too close to a critical speed, and then they get into the critical speed, and then it's, oh my God, what are we gonna do now? They get scared instead of go ahead and taking it on up and getting on through it. So, and your manuals call out for the critical speeds, what they are. So, then once you get up on minimum governor, once the governor gets it, and it lays out, let it sit there on minimum governor for a few minutes, 10, 15 minutes, and let's make sure, let's walk around, make sure we don't have any leaks, make sure we don't hear any unusual noises, and then once it's stabilized at minimum governor, you can go ahead. You know, you can take it right on to whatever speed you need to. Most of the time, critical's in the 2,100 to 2,400, just theoretically speaking, across the board rule of thumb. could be a little higher, a little lower. But once you get up above that, and you get up on minimum governor, and everything's laid out, you can go ahead and start bringing the speed on up on it, once it stabilizes at minimum governor speed. So. A lot of times people, it's hard sometimes for production to let you start them up like that, you know, they're right down behind you, you know, wanting to go, we gotta get a sheet on the reel, or we gotta get power coming out the end of her, or we got a 500,000 barrel day refinery down there, man, he's ready to get her going, it don't matter, so.
So what would you say would be as far as the idle speed, letting it set and warm up, the minimum?
Yeah, whatever, most time it's in the 600, 700, 800 RPM range. Just when you start rolling it off, and you start putting steam into it, and you see it starting to roll, let her sit right there and let her stabilize, and try to, you know, cause once it rolls off, you'll see it go 3, 4, 5, start creeping up. Just keep backing down on it until you get a steady idle speed, 5, 6, 7, 800 RPM. I know the line shaft turbine, we couldn't control it hardly below 700. So we left it right around 750, and just let it run right there. That way, if you have, even if, that'll also, you can walk around and listen for any rubs, squeaks, anything like that, so. And it gives it time to warm up, so. As low as you can control it, basically, you know, whatever speed you can control it at. Cause you try to get too low, and then you try to open up a little more, and then here you go, it won't go up 1200, and then you try to back down, and before you know it, you're down there, just now you want to do nothing. So wherever you can control, what a steady, controllable speed is. Larger steam turbines typically use an electronic governor and trip throttle valve arrangement. To start this type of machine, press run on the governor and slowly start opening the TNT valve. Turbine speed will be controlled by opening the TNT valve until the governor minimum controlling speed set point is reached. This set point could be slow, idle speed, or higher minimum governor speed. That's all how you got your governor set up. Typically, you don't see a startup that controls low speed being the idle speed. Just most time the minimum governor right above critical. You know, most time the governor don't get it till you get on up on the bigger machines. On the smaller machines, a lot of time the governor take over 1,000, 12, 1,400 RPM. But it's just a matter of way you got your governor set up. Whatever works best for y'all, so. We don't really dictate what speed you set it at, whatever you're more comfortable with and what works best for y'all. If the turbine uses a standard type trip valve and mechanical governor. Once the trip valve is latched open and the operator opens the turbine inlet isolation valve, the turbine speed will automatically increase up to governor minimum speed. That's when you need to control it with the valve, with the trip valve. Because now they just keep on creeping up till the governor gets it, and then that's the end of that. The governor's got it then. So you need to keep it down. That's what I'm saying, keep it at minimum controllable speed that you can, and let it just run in.
You use a throttle valve on that?
Mm-hmm.
You use the throttle valve on that?
Yeah. On these smaller machines with carbon seals, it's as important warming those up as it is warming up a big machine. These carbon seals, they're manufactured, they're 3-piece carbon seals, and they're manufactured with design clearance made into them. If for some reason, and probably 90% of the people that install these seals never put all 3 segments together and check the clearance on them. So when they're putting in, if you have 1 or 2, or just one that has, the clearance is too tight on it, that won't allow the shaft to thermal growth to expand it and take up the clearance, that carbon will grab that shaft. And I saw with my own eyes at ExxonMobil in Baton Rouge, a carbon ring grabbed and bent the rotor and tore all the blades out when it bent the rotor, rubbing on the case over a carbon ring. Typically, I try to make, in our repair centers, it's a lot easier to do in the field. It's kind of hard to have special tooling, little knickknacks set up that make the job easier. But we take a mammal and machine it, you know, with X amount of clearance, you know, whatever the clearance is supposed to be, whatever size the carbon is supposed to be. and keep graduating up in 1,000 increments. So you can put those carbons together and slide them down over the mantle and make sure you got the right clearance. Because they're just like everything else is man-made, you know. Might be Friday afternoon, he's ready to get to the house. Let's put this one in a box, so.
We'll take a, is this all right place to,
Yeah.
we're gonna take a break here.